Hello. In your assignment, you have some problems where you have to find the five main features and sketch the graph of quadratic functions that are given in terms of parameters a, b, q, b, and so on. Many of you had questions about how to exactly approach these questions, so I decided to record a video doing an example. This is not any of the examples from the assignment, but it's similar. So the quadratic equation we wish to analyze is given by y equals a times x minus b. And it is given that p is a positive number and a is a negative number. So I'm going to start by saying that then we know that the concavity is negative, since it is given that a, the main coefficient, is negative number. Now we can find what are the x-intercepts. This is also going to be given in terms of the parameters, so we're not going to be able to answer the x-intercept as is at the point 17, 0 or the point minus 3,0. Our answer is going to depend on a and p possibly. So we need the function to be equal to 0. And this is true when x is equal to 0 or when x is equal to p. So our x-intercepts are the points 0, 0 and p 0. And remember, p is a positive number, so that's going to be important when we try to sketch the graph of our function. For the y-intercept, we need to evaluate the function when x is equal to 0, so it's going to be a times 0 minus p. And all of this is 0, but actually we didn't really need to do this because once we saw that 0, 0 is a point of the function, it's an x-intercept, but also has x-coordinate 0, so it's also the y-intercept. So we don't need to look any further for it. So now we need to find the axis of symmetry, and that's going to be halfway between the two x-intercepts that we already know. So it's going to be x equal, well, halfway between 0 and p, we have the point p over 2. So the vertical line through p over 2, so x equals p over 2 is the axis of symmetry. And once again, note that p over 2 is again a positive number. We need to find the vertex. We know the x-coordinate of the vertex, that's p over 2. So we need to evaluate our function at p over 2. So a times p over 2 times p over 2 minus p. So we get a p over 2, and then inside the bracket, what we have is p over 2 minus, I will take common denominator 2, so 2p over 2. So this is minus p over 2. So this is a times p over 2 times minus p over 2. We can write this as minus a times p over 2 square. Notice that a is negative, so negative a is positive, and then we have the square of a positive number, so this is also positive. So the y-coordinate of the vertex is a positive number. And I'll write the coordinates of the vertex together here. P over 2 minus a times p over 2 square. Okay, so let's go ahead and sketch the graph of this function. Let's see over here. These are going to be my axes, and of course we don't know exactly what is p, but I'm gonna position it here as a positive number. So we have one x intersects here and the other one here. Halfway, I need to draw what is going to be the axis of symmetry. That's over here. And it's at x equals p over 2. And now I need to also locate the vertex. We know the x-coordinate is in the vertical line. And then we know that the y-coordinate is a positive number. So I'm just picking here a positive number. So over there it's going to be my vertex. And this is the point minus a times p over 2 square. So I have 3 points to draw my function. That didn't look well. Let's try again. Okay, so just gonna complete my graph a little bit. I don't need to go down so much. I don't need to go in this direction that much either. And then this is the function y equals 8 times x minus p. This is the point 0, 0, which is an x-intercept, and it's also the y-intercept. I have the other x-intercept here at the point p0. And over here is the point p over 2 minus a p over 2 square. And this is my vertex. And the vertical line I marked over here. This is the axis of symmetry. So now my sketch is complete.